Let's go give it to him. Math 44, welcome back, everybody. We are working on rational expressions. This is 5.6b, not expressions, rational equations. And these will be the bigger examples. So let's do 3 over x plus 1 minus 1 over x plus 4 equals x plus 12 over x squared plus 5x plus 4. Thing we want to do is find the domain restrictions. To do that, I'll factor this. We're setting it equal to 0. We factor it. We get x plus 4 and x plus 1. So both of those are domain restrictions. Restrictions in our first problem. X plus 4 cannot equal 0. X plus 1 cannot equal 0. So x cannot equal -1, and x cannot, if I subtract 4, x cannot equal -4. So keep those in mind. My LCD, x plus 1, x plus 4, and then both. We should be able to see it's just the one at the end. This has x plus 1, this has x plus 4, this has both. So the LCD is both. That's what we're going to multiply through by. So I'll show you the long way of doing this, which is to actually multiply through by it. And then we simplify. That cancels, and I'm left with 3 times x plus 4. That cancels, and I'm left with minus. That should have been the x plus 4 there. So that one's still there, and the x plus 4 cancels. Minus x plus 1 equals, both of those cancel, and I'm just left with x plus 2. That's the long way of doing it. With the table shortcut, holes in the table are what the numerator gets multiplied by. And then so we'll see the x plus 1 is missing the x plus 4. I multiply the 3 by x plus 4, and I drop the denominator, I get this. The x plus 4 is missing my x plus 1. So I take the -1. Maybe I'll put the -1 in. The 1 in. And I just multiply by what's missing and drop the denominator. The x plus 2 wasn't missing anything, so I don't have to multiply anything. I just drop the denominator. I don't know if you like the table shortcut. It works pretty well. At this point, we distribute 3x plus 12 minus x minus 1 equals x plus 2. I will gather like terms. I will gather I'll get all the x's on one side. Since it's not a quadratic, or x squared Get the x's on one side and the numbers on the other. I get x equals -9. X equals -9 is not a restriction. So x equals -9 is good to go. All right. Next example. Six over x plus 2 plus 5 over x minus 2 equals 20 over x squared minus 4. Go ahead and work that out. See what you get. Pause the video. I will assume you did. This factors is a domain. It's a difference of squares. So like the last problem. Oh, restrictions first. Restrictions. X minus 2 cannot equal 0. So I add 2. X cannot equal 2. X plus 2 cannot equal 0. X cannot equal -2. Now I do my LCD table. I have x plus 2 on the first one. I have x minus 2 there. And I have both here. So my LCD is the final fraction denominator. If you follow my shortcut method, the x plus 2 denominator is missing x minus 2. So this ends up being 6 times x minus 2. The denominator with x minus 2 is missing x plus 2. So that ends up being plus 5 times x plus 2. And the x squared minus 4 is not missing anything, so we just drop the denominator. All right, we will distribute 6x minus 12 plus 5x plus 10 equals 20. I combine like terms, I get 11x minus 2 equals 20. I add 2 to both sides, I get 11x equals 22. I divide by 11 and I get x equals 2. I check my domain restrictions and bam, x equals 2 is bad juju. Alert, alert, red alert. X equals 2 is a restricted number. It doesn't work. So we have to cross it off. And since that was our only solution, no solution to this problem. You'll see if we stick x equals 2 in up here, it breaks that one and that one. Both denominators turn to 0. All right. One final one. X plus 3 over x squared minus 6x minus 16 plus x minus 4 over x squared minus 4x minus 32 equals x plus 1 over x squared plus 6x plus 8. Go. All right. So I'll assume you did. I'm going to rewrite these as with factor denominators so I can see what it looks like. This is x minus 8, x plus 2. So I'll start making my table here. So that's x minus 8, x plus 2. This looks like x minus 8, x plus 4. And this is x plus 2, x plus 4. So my LCD is x minus 8, x plus 2, x plus 4. For domain restrictions, I will set that equal to 0. Each one of these gets set equal to 0. X minus 8 cannot equal 0. X plus 2 cannot equal 0. X plus 4 cannot equal 0. So x cannot equal 8, negative 2, or negative 4. Those are my restrictions. All right, holes in the table method. The first fraction with the x plus 3 on top is missing x plus 4. So I'll dump the denominator and multiply this by x plus 4. The second fraction with x minus 4 in the numerator is missing x plus 2. So I'll dump the denominator and multiply by x plus 2. You can go through and do the multiply by the LCD and clean up like I showed previously, or this shortcut method works great. But if you're going to use the shortcut method, you better use the table, because otherwise I'm thinking you cheated, like with Photomath or some shit like that. Yeah, I know about those apps. X plus 1 drops the denominator, multiplies by x minus 8. All right, we clean up. This is x squared plus 7x plus 12. This is x squared minus 4 and plus 2 is minus 2x minus 8. And this is x squared minus 7x minus 8. Gather like terms. Since it's quadratic or has x squared, I will move everything to the left by subtracting the opposite or adding the opposite. Get x squared plus 12x plus 12 equals 0. I don't think that factors. Did I come up with a bad problem? Let me check my work real quick. Minus 8 plus 2 is minus 6. Minus 16, that's the right factorization. Did I write my problem down right? Yeah, I did. All right, so minus 8 plus 4 is minus 4. Those multiply negative 32, that works. 2 plus 4 is 6, and they multiply to 8, that works. X plus 3 times x plus 4. X minus 4 times x plus 2. X plus 1 times x minus 8. 3x and 4x is 7x. Negative 4x and 2x is negative 2x. And negative 8x plus x is negative 7x. And I got all my products correct. Did I gather like terms correctly here? 2x squared, 7 minus 2 is 5. 12 minus 8 is 4. Minus, plus, plus. Ha! we haven't gone over the quadratic formula. If I try to factor this, multiply to 12 and add to 12, there isn't anything. I've already skipped the 12, so this does not factor. There is a way to solve it. We haven't done it. And I'm not gonna, I'll show you how to do it, but I don't think it's in this class. So the way you do it is the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac over 2a, where we're in the form ax squared plus bx plus c. So for this problem, a equals 1, b is 12, and c is 12. So I'd have negative 12 plus or minus 12 squared minus 4 times a times c, all over 2 times 1. And we haven't covered radicals yet. This is 144 minus 48 is 96 in there, which I know simplifies. But we haven't covered that. This is not a problem I wanted to use here, apparently. Neither of these are going to end up being negative 2 or negative 4. Because if they did, it should have factored easier. Okay. I guess we'll wrap that up with there. We've done enough complicated ones. Peace.